So the Sims are all based on research that we've done. So there's research on how people learn, that's just general research, and then there's also in-house research on how effective the simulations are. So that research base is what informs this design cycle, where we define what the learning goals of a simulation will be. We come up with an initial design after many tweaks. The developers create a test version of it, and then we actually do user testing with students in interviews where we see how they use a simulation. We don't give them any instruction on how to use it. We just say, play with this sim and talk out loud while you're using it. So we get insight into what students are thinking when they're using the Sims and how they're working through it, and are they getting to the learning goals we had in mind? Are they finding the controls we want them to find? All the information from those interviews goes back into that research base to keep improving and refining our design strategies for these Sims. And then we do tweak and iterate on that cycle a few times, where we change the design a little bit, do some more interviews just to make sure that they're really polished. Sometimes we do classroom research. That's usually tied to a grant, so we did some 2 years ago in some classrooms in St. Vrain. And then again, that informs our research base, and all that goes into that final design that's published on the website. So this whole cycle for one simulation can take anywhere from 6 months to a year to do one sim. So what interactive simulations are, and it doesn't look like it just having this list here, but they are very engaging. They're very intuitive and easy to use. Students find them deeply enjoyable to use them. They get excited. You hear a lot of chatter in the room. They link representation, so things that you've been saying, you know, these are the same thing, they're explicitly linked in the sim and dynamic. So when you update one thing, something else in the simulation updates, and often connect to the real world. So here's an example of a sim, and you guys are going to get to play with lots of simulations today. This is our fractions intro sim. So I just wanted to point this one out, how it has some of these design features. So when you open up a sim, you'll see these 3 screens on a home screen. So this is a way to scaffold this information so that you're starting with something simpler before adding on representations or perhaps increasing the complexity of the topic. And then within a sim, there's also scaffolding. Sometimes, like in this sim at the top, there are these different representations, and it really intentionally starts on this fraction one with the pi representation before moving on and ends with the number line representation. So that's part of the scaffolding. Here are these multiple representations. So while the fraction is changing there, this representation with the cake, this numeric fraction is changing at the exact same time. So you can change one and the other one changes as well. And they're really intuitive. So something like a bucket we know is really intuitive for students. They know they can grab things and pull them out of there. So there are certain design things like that in the Sims that we know students know how to use. And buttons, that's another thing that we know students know how to use. And then this really powerful action in this sim, you can do things with this technology you can't necessarily do with a physical manipulative or with a lecture. So you can change the size of that denominator piece with just the click of a button. That's really, really powerful to say, I'm looking at 11/6 here. What happens if I'm looking at 11/7? How does that change the fraction? How does that change the value? How does it change the appearance? Not to say there's not a place for those physical manipulatives, because those are really important. And so I think something like this, you could even pair with those manipulatives at the same time. So we're going to get to play with these, I promise. But I just wanted to share that piece. And then there are many, many ways you can use Sims in your classroom. So we've designed them to be really flexible tools so that in any classroom setting, any teacher, any level of comfort they have with technology or even hands-on activities can use a simulation. So you could use it as a demonstration, where something like this, if the teacher's driving the sim in the front of the room. So I could have it projected, I could be demonstrating for you guys how this fraction works. Right? That's a really simple way to jump into using a sim, and especially if you don't have a lot of technology. You could also use it where the teacher's still projecting it in front of the room and still engaging in a discussion with your students. You could be asking prediction questions. What do you think is going to happen when I press this button? How do you think we could build this fraction? And the students can sort of engage with the sim in that way, and they can also create their own predictions and test them using the sim in front of the whole classroom. And the third way is a guided inquiry activity. So in this scenario, the students are the ones engaging with the sim. They're the ones driving it, using it. We're not using it. We're not telling them how to use it. They're controlling it. They're tinkering with these different concepts and exploring in this really open play space. And then all the students, the goal here is that all of your students are reaching the same learning goals, but potentially taking different paths to get there because of the nature of these sims. They could all be building different fractions, but potentially still be getting to the same goal of understanding what a fraction is. So this is where we are going to be spending a lot of our time in this workshop, is this guided inquiry setting. And that's what we're going to be writing our lessons. We're going to be modeling them with this guided inquiry lesson model.